Hello guys. So in this tutorial we are gonna look about something called automating vision model selection using LLMs and MCP. So our starting point for this tutorial will be a registry of registries. So imagine there is a particular registry called registry A of that belongs to certain company, and that company has its own models, like there can be any LLM model or a computer vision model or audio model or things like that. Now imagine there are such so many registries, like some 10-20 registries, right? So given a particular let's say a user is interested in just executing his particular task, but he doesn't care which registry is used, or let's say he specifies a certain registry. So in such cases there is this registry of registries concept. So registry of registries is nothing but it contains the whole details about all those 10 to 15 registries in a single registry. So the LLM or some tools has to select which registry to use for the given problem statement from the user, right? So let's say the user is giving, as you can see in this tutorial, the user is giving, they want to do a vehicle analysis, right? So out of n registries present in the registry of registries, the LLM or a tool has to select one, or as per the logics, it has to select some some subset of registries out of it. In this case, we will be selecting one registry out of some 3 registries. So that is the registry of registries concept. So that's where our starting point will be. And in this whole tutorial, all the important decisions like selecting the registry, selecting the models for the inference, all those decisions will be taken by the LLM itself. And that's what we are calling as a LLM driven registry selection. And since the LLM is deciding the registry, it also decides which assets, which models it has to use within that registry. So there is a dynamic model discovery as well. And then we will pass to something called a pipeline composer, which when it gets some n models that the LLM feels relevant, pipeline composer comes up with a final pipeline which the LLM can use it to execute the calls, basically calling those models in a certain way so that we can get the final result. So this is the high level architecture. So you can see in the first step, actually since every decision is LLM, I'm just highlighting some of the important things in the architecture. That the first stage will be to discover the what all registries are there as a MCP tool, and then connect to the registry that the LLM decides. And then in that particular registry, the LLM has to use the MCP calls to understand what are all the available models, assets in that registry. And then the LLM filters the models as well, right? Out of, let's say, some different kinds of models, there can be any number of models in a given organization, right? So it filters those models and sends the relevant models to the pipeline composer, and the pipeline composer comes up with the final sequence that the models has to be executed and pass it to the final stage where the LLM will call the individual tools, which is in this case individual models, right? It will call them in that order so that we will get the final result. So the key principle is everything is MCP based, and LLMs are used to discover the registries, models, and execution order through MCP tool calls. And there is no hard-coded selection logic in any part of this, except what we supply in the prompt to guide the LLM, right? So let's see how this goes. Okay, now let me just go through how these registry of registries and these individual assets registries are created for this tutorial. So we have this folder structure, right? In the main folder structure, you can see something called data, and this tutorial notebook is present here. And we also have the Nginx, and I will explain why it is required. And we have this Docker Compose. So these are the important files and folders. So let me just open this data folder first. So here you can see we have a set of JSON files, right? So let me open this registry of registries, so that this is our starting point. So now, as you can see, the name of this, consider it like a meta registry kind of thing, where we have the data of all the individual registries. So we have this name, registry of registries. We have a description, central registry containing information about all available service registries. And I'm giving an endpoint. We will come back why it is required. This is actually the MCP related endpoint, and we are accessing via MCP API. And of course, we have this registry of registries capabilities as registry discovery, service discovery, and all. Right now, if you see under this, and of course, this particular registry of registry is for AI services, computer vision, pipeline orchestration. It can have any kinds of things, right? So within this, if you see under services, you can see there is something called OpenOS registry. So this OpenOS registry, it has its own registry. It has its own MCP available in this particular URL, and it has a description: OpenOS.ai asset registry and models for general AI and computer vision tasks. So you can see the capabilities are containing computer vision, object detection, vehicle detection, license plate detection, OCR, vehicle classification, color detection, tracking. So some of the vehicle related capabilities, and the domain comes as automotive surveillance and all. So similarly, we have two more registries. One is called RoadNet. It has its own registry URL. So you can see road network analysis and traffic, computer vision assets and models. And it also has some similarities with the previous capabilities. It has road analysis, traffic monitoring, license plate recognition, and apart from that, just to confuse the LLM in the initial stage, we have a weather classification, pedestrian detection as part of this also. And also we have another AI center registry, right? So it has its own inference training as the capabilities, the important capabilities, and it has its own registry URL. And this is the pipeline composer. So you can see the capability as pipeline composition, workflow management, pipeline execution, and it has its own registry URL. So its description is given as compose and manage AI and vision processing pipelines, right? So you guys can explore further what other contents are there. But the main reason for explaining this is to give an idea about what a registry of registry can look like, right? So basically, we have to summarize the registry of registry. Basically, we have this kind of we have to approach this kind of pattern for this. Like, we first need to discover the available registries from the registry of registry, and before that, let's be clear what is our goal. So the goal is the user gives a query, right, saying I want to do a let me show you the query itself. So here you can see the user is saying, here is an image file. Using the OpenOS registry, extract vehicle attributes from this image. This will be the typical query that we get from the user, right? So the below things are other system prompts. We'll come back to that. So all the user will is giving is, he wants to analyze the given vehicle image for vehicle attributes, and he is also telling us to use the OpenOS registry. So with this as the input, our approach to solve this problem is, we need to discover the available registries in the first place. Then we need to explore the registry capabilities, right? Like once the LLM decides which registry to use, and of course it decides based on certain capabilities, right? Once that is done, then we need to, then that registry's models needs to be understood by the LLM, so that it can construct a pipeline and execute it, right? So in this tutorial, we have this, like I said, OpenOS AI Center RoR registry. And why it is important is, tomorrow, let's say in an ecosystem, another user or another organization has put up their models as MCP. They are giving their registry and registering in the Registry of Registries as well. Then it is possible that the user can start using any new onboarded organizations easily, right, without any other change to their any of the flow. So that's the purpose of this kind of Registry of Registries concept. So let me print some of the details that we are actually sending to the LLM. So I'm passing the Registry of Registries JSON here, and I'm selecting certain keys from the Registry of Registry. So for example, I'm selecting the ID, name, registry, description, capabilities, and domains, right? So you can see that the capabilities and domains are also going for the LLMs here for each of the registry, right? And the LLM is supposed to select one registry based on the given query. So this particular this particular MCP tool, right, it is available as part of the servers. So in servers, we have since we are running all of these MCP tools, right? Again, all these are public MCP examples, right? So here we have this Registry of Registries. Now you can see that we have this tools. So let me, so here you can see the ID, name, description, capability, domains, right? So it is available here. So these are the MCP tools: registry list, registry servers, registry MCP tool. We are sending the registry list with this kind of the registry info, so that the LLM can understand which one to select. And then once it understands which particular the registry to use, then it will send the particular registry ID, and with that we will also add this particular registry detail as a tool to the LLM. So the actual driving code is available here in the MCP client code, Jupyter MCP client code. So this code contains all details related to how the MCP tools are called and how they are added as part of the LLM and all. So here we are using the ChatGPT's GPT 4.1. We are using their REST API calls. So here you can see how they are actually used to how the tools are added as part of the LLM, right? So now coming to the prompt goes like this. So this will be the typical user message that we get, and this is a let's say a backend kind of message that we will append to the user prompt. So what we say is there are three phases in the flow. One is the discovery, where the LLM has to discover the available registries using registry list. So this is the starting point for the LLM, right? And use registry servers to get the asset registry MCP server URLs, right? So these two particular tools are already available here: registry list and registry servers, right? So we are pointing the LLM at the beginning, guiding the LLM to say so that it can call these MCPs and then get the required data. So we are also saying connect to asset registry, get metadata and list available models. And then we are saying identify vehicle related analysis capabilities and extract model URL. So what is this? I will explain in a minute. So here, as I was showing in the data folder, there are so many JSON files. So we started with the Registry of Registries. Now let us go and check one of the actual AI registry, which is nothing but OpenOS registry. So in the OpenOS registry, you can see it has its name and the description, and its registry URL is also given here, and the model URL is also given. right? And now what is the, and of course the capabilities, domains, assets are other things, but what is this model URL? This model URL is another, it's this model URL contains the actual implementation of the models and which are exposed as MCP tools. So now here you can see it has these models available, right? Models containing detect color, detect plate, read plate, detect make model. And just to confuse the LLM, we are also supplying other tools like classify weather, detect pedestrians, gender detector and all. Now all these are, all these model information goes to the LLM, and the LLM is supposed to select the correct set of models out of this, right? So for this reason, let me again go back and show. In the servers folder, you guys can see we have this MCP2 OpenOS assets.py. So this is the OpenOS's registry MCP tool, and we also have the OpenOS models tool as a MCP, right? So in the OpenOS assets, what we are saying is we are basically telling the LLM that it has, the LLM will, since it's an MCP, the LLM will identify what are all the tools available. Even though we call these as tools, right? So even in the registry of registry, let me go there. Yeah, even though in the registry of registry, what is actually a tool? A tool has to give a full, it has to have a full functionality. A calculator can be a tool, right? Similarly, sending an email, that can be a tool. But not every, small intermediate steps can be a tool, right? So, but in the fast MCP world, typically they use this term tool for everything. Whatever functions we register, it can be a tool. But in the AOS and in the AGI grid, we have a different way of doing this, and typically we have something called registry grid, which will be used to use the registry of registry kind of concepts. So the LLM uses these kinds of MCP tools to understand what are all the assets, the models available in each registry, right? So again, this tool discovery, or in each call, what are all the tools that the LLM has discovered, and so that we can register those tools to the LLM, right? In this case, the OpenAI's ChatGPT. Those things are controlled in the Jupyter MCP client, which you can refer, right? So basically, we have all these things running in a loop till we get a final completed response from the LLM. So once it discovers any new URLs like this registry URL or model URL, it registers that URL, and then the LLM takes a call whether it has it needs to use that URL or not. So coming back to the prompt, so it will connect to the asset registry. How it connects? Via the the URL that is available in the JSON file. So it uses the registry URL to connect to the registry, that particular selected registry, and it will identify all the available models, right? Now how it will do that? So first of all, it has the models data here itself, right? So it can use that to understand whether select the right set of models, right? And then it will, that's what it will identify vehicle related analysis capabilities and extract the model URL so that it can later start use it for actual execution, right? So the model URL is also available here, right? And we are strictly saying that it should not call any analysis tool before getting pipeline, and we are saying do not register model servers yet, right? So because we want the LLM to execute the model calls as per the pipelines planning. So the next phase is the pipeline planning, where it will connect to the pipeline composer service from registries. So during the registry of registration, we saw OpenOS, RoadNet, AI Center, and also a pipeline composer. This is like a generic pipeline composer where you give a set of models. It will compose a pipeline and give it back to you so that the LLM can run it in that particular fashion. So the pipeline composer will receive the necessary models selected by the LLM. So that's what this particular filtering stage refers to, right? And then the pipeline composer will give the final execution plan, right, in the certain order. And we are again saying do not register model servers here again, just to make sure the LLM doesn't call unless we go to the next stage. So, and the code for that pipeline composer is here. And again, these are all the Py files that you see here. They are exposed as public MCP tools for this demo. And here you can see the pipeline composer. What it has this compose pipeline tool. What it basically does is it receives a set of models, right? And to make things simple and for a demo purpose, what we have done is whatever tools we get, we simply parse that and return it in the order that we get. So, and this is the return pipeline step. We are saying pipeline steps contain the pipeline tools. The execution order is sequential, and we are giving extra instructions also here, and the total steps meaning the total tools. So the LLM has to receive this particular set of order, and then it has to execute the models in those order, right? So I will also show the demo in a minute. And then towards the end, we are saying the execution pipeline. Register the model server from phase 1. Execute, because it has extracted the model URL from phase 1. Execute analysis tool in exact order from pipeline composer. Use only the tools specified in the pipeline response, just to make sure it doesn't use any other tools here, right? And some critical rules also we are mentioning so that the LLM doesn't randomly calls any tools that it finds. And here we are also saying it has to start with phase 1 and go to continue with phase 2 and phase 3, right? Just to make sure the LLM doesn't terminate any of the, doesn't get stuck in between for any response from us for this demo, of course. So in short, we have the registry list is used in the initial stage, and the registry servers are also, again, all these are MCP tools, the registry list, registry servers. LLM is expected to make the intelligent choice of selecting the registry. And how it does, it reads the MCP tools description and also the registries descriptions that we have added in the JSON files. So note that there is no hard-coded logic. The LLM is taking the final decision based on the input query from the user. So now coming to the model discovery process. So the LLM sees these vehicle relevant models, the detect color, detect plate color, detect plate, read plate, detect make model. And just to confuse the LLM, we have also added classify with detect pedestrians and gender detector. And the LLM must analyze all these discovered models and intelligently filter them, right, before sending it to the pipeline composer. How it does is it uses the model name and the descriptions and the input and output kind of information, right? And then it will send the filtered list. So again, all these are MCP calls that I just showed you. So here you can see, the model tools. We have kept it simple for this particular demo. We are using the fast MCP, the detect color, detect plate color. We are returning simple hard-coded values for now for the demo. And you can see classify whether detect pedestrians, gender detector are also there as a confusing tool to disturb the LLM. And in reality, here we will have our own individual models calls, right? You can have a call to a particular gRPC model here within the detect plate color, right? So that's how in reality the actual implementation will be, right? So now let me move on to the demo. So I'm basically importing the necessary functions here, right? And I'm giving the first URL that I'm passing to the LLM I mean, of course, the URL that is nothing but the MCP URL, so that the LLM can discover the tools within that MCP, and then which is nothing but the Registry of Registries tools, right? So that is the only URL I'll pass, and I'm giving the model selection as GPT 4.1 for now. So like I said, it will go in these 3 phases: the discovery, planning, execution as per the prompt also, right? So here this is our execute MCP vision pipeline. We are passing the image path, registry URL, model, and we are giving verbose true. And don't forget that we have all those the necessary files here. So we have this Jupyter MCP client. Inside it contains the functions that we are calling. Now you can see what the outputs are here, right? Let me even run it. So it is starting the MCP vision pipeline with GPT 4.1, and I'm passing a sample image just to simulate this scenario. As you can see, it is still going on. So what it is basically doing is, in the first round, it uses this particular registry URL. It looks for certain other registries, and once it finds any other URL, then it goes to the discovery round 2. And then what it means is, it uses the first URL that it detected as part of the tool list of the LLM, right? And then using that URL, which is nothing but the, let's say, in this case, it is the OpenAGI registries URL. And within that, it will start looking for other URLs, especially the model URL and other tools, right? So that's why it has gone to discovery round 3 also. So here we are printing the actual response that we are getting from the ChatGPT's OpenAI's chat response. So here you can see it is saying a response MCP call completed event, the sequence number for all these steps also, right? So it will take a minute. So I'll just explain other things here. So what we basically then do is, we will write that response to a to a text file, and then I will show by parsing how the what is the actual thing, how the tool calls are happening in that particular run. So there you can see how the final results are coming. And of course, to run all these endpoints, we have this Docker compose file, where we run all these the services, the Registry of Registry service, MCP2 open assets, pipeline composer, roadnet assets, OpenOS model tools. All these we are running it as a service and exposing via Nginx, right? So that and we are using ngrok to make it as a public URL for this demo. So once you guys use this Nginx file and also this particular Docker compose file, you can up all these particular individual MCP tools. So let me go back. So I think it's going to complete now, because by now it should have found it has reached discovery round 4, where it should start executing some of the individual models that it has discovered, which we'll see now. So now I will run, it has run. Now we'll run this part of the code to write it to a text file. So basically it has found this many items, and now let me pass the response and show you how the output looks. Yeah, so now here you can see how the flow is. Let me enlarge it. Yeah, so initially the first call is for registry list on server RoR. RoR is nothing but the Registry of Registry. It has found all the registries here, right? You can see that there is a OpenOS registry, there is a roadnet registry, and there has to be one more AI center registries also there. And then it uses the LLM sends these arguments OpenOS to the tool, and it finds the necessary data with this it extracts the server URL, and then it sends the basically it will query for this particular OpenOS assets. It understands what are all the assets, the models and everything available in this. So now you can see that it has this model URL also that it receives, and then it is asked to list its models. This is the registry metadata, and here it is asking it to list its models. Here you can see we have all the tools. So for example, detect plate color, detect plate, read plate, and to confuse we also have passed classify weather conditions on the road images is its description, and gender detector, everything is there. So it has basically completed the phase 1. So this is the LLM's output, and it has found all the models here. In summary, it is giving me. So then it is going to phase 2. It is planning for the pipeline. So it is calling the pipeline composer. It is, if you can see, it has found these models, including the weather, pedestrian, and detector. But when calling the pipeline composer, it is sending only the models that matches the query, right? And then the pipeline is returning it in a certain order, right? The make model comes first, and the read plate comes last. Yeah, this is its summary, right? The phase 2 summary. Then it goes to the phase 3. It starts the call to the individual models. You can see it is calling detect make model first. It got the hard-coded value here. Then detect plate color, then color, and the order is available here. Then towards the end, it is reading the read plate. So as a summary, it is giving the final, the make model, body color, number plate text. So the LLM has basically, dynamically discovered all these and executed as per the pipeline. So this is the final output, right? It has given it has completed the phases like we have instructed, and it has extracted the final output. So so this is the overall workflow in the 3 phases, and so basically the outcome of this demo should be that everything is being discovered through MCP tool exploration by the LLM, and there is no hard-coded logic. LLM makes all the choices, and the pipeline orchestration is used to instruct the LLM on what order that the models can be executed. This is a bit crucial, and like if you want to if you have your own way of executing or constructing the pipeline, which is what will happen most of the time. So for that, you can refer this particular tutorial. We have this pipeline, RAG based approach to compose pipelines. Especially you can find it here under this tutorial, Auto AI Expert, RAG based, right? And there we have a YouTube video also explaining how this is actually done, right? And if you are interested more in using your own LLM model or any of the LLM model from the AI Grid, I request you to check this particular tutorial, right, where we explain how typical different model like Gemma model, Llama 3 and all, how they are, Llama 4, how they are onboarded, or how we can use that in the AI Grid. And we have the corresponding Jupyter notebook also here. So with this, what we have basically achieved is an automatic vision pipeline using MCP and LLMs, right? And for the pipeline, the models are selected by the LLMs. So, and in case you get into any of the issues, I request you to check this troubleshooting steps. You can, to understand more about the individual what's happening in individual MCP, I request you to check the individual logs of the those container, because like I explained here, each of this service will run as a container. You can check their logs to understand what is happening you can print something and get more idea like what are the input tools that is coming to the pipeline composer, input models coming to the pipeline composer, and what is being sent back. So those kind of things you can add some logs and get an idea about what is happening in overall. Right. That's pretty much it. I'll see you in the next tutorial. Thank you.